Hi, today we're in Cambridge, Vermont, and we're at a 1989 Cape owned by Jim Bradley of Caleb Contracting. Jim is taking the opportunity to do some deep energy retrofits on his house and finish things off. And it gives us an ideal opportunity to look at the types of construction that were going on in the late 1980s and early 1990s, what they were doing wrong from a building science point of view, but also to look at what a lot of builders are still doing today in the field, which causes issues with thermal bridging, comfort, heat loss, energy loss, and durability. So here we are, we're inside the house now, in a part of the house where it's an old part of the house, 1989 construction, which is classic late 80s construction, early 90s construction, with a 2x stud that's either a 2x4 or 2x6, filled with fiberglass insulation, and then a sheet of polyethylene plastic on top of it as a moisture barrier. The first thing we're going to notice here is the class of insulation installation. There are three classes of insulation installation, 1, 2, and 3, 3 being the worst, and this is a classic example of class 3 fiberglass insulation, where the thickness of the insulation does not come fully up to the stud, where the edges are rounded in, and when there are gaps of up to a quarter of an inch in various places in the assembly. If we look up here, what we're going to notice is at the top, you get a discoloration of the insulation. That discoloration is caused by one of two things. It's caused here by some mold that was growing, and over here it's caused by infiltration. So wind and air blowing against the house, coming through the exterior sheathing, through the insulation, and carrying dust with it. And then, of course, the opposite, when the house is warm and air is leaking through the band joist, dust in the house, going through this, and the fiberglass acting like a filter. So here we are. Just wanted to show you this detail. This is a corner detail between the original part of the house from the late 1980s to the new part of the house that was built in 2009. What we have here is that classic 2x6 construction with the fiberglass inside and the poly sheet. And in the new part of the house, what we have here is Jim used some repurposed EPS, which is styrofoam like you use in a coffee cup. And over here we have another type of insulation. This is closed cell spray foam. Now closed cell spray foam is mixed on site, so it's actually manufactured where it's installed. And there are a lot of different problems you can get with spray foam, but I wanted to show this because this is actually a very good application of closed cell spray foam. What we have here is a very even spray. We don't have any voids, there's no discoloration, it's not orange, which would mean that the mix was wrong. And what we also see is that after 7 years and opening this wall, that there's no separation from the wood, which means that the substrate, the wood, was in a very dry and dust-free state when it was installed. That's what we like to see when we're talking about using spray foam. We don't often see it that well installed. I just wanted to take a moment to take a look at this corner because in the next half hour or so, Jim's crew is going to come in here and they're going to take this beautifully stuccoed ceiling out. And that's going to give us access into the band joist up there. And this is actually a 1.5 story cape. So what we're going to see when we take that ceiling out is the roof line going up. Now Jim did a renovation up there years ago when he was just starting to learn about building science and knew a lot about building, and he did the best he could, but he just admitted to me that what he put up there as far as insulation was concerned was just some fiberglass, because at the time he was taught that that was not only insulative but also air sealing, and we know different now. So just a word to all you builders, learn as much as you can about building science right now and use that building science, but constantly educate yourself, because Jim would never do that detail now the way he did back 2009 when he did that renovation. He's now learned enough to know that that's not going to be an efficient way to use insulation. It's not going to cut down the air leakage at all. So here we are in the old bathroom. It's being removed, and just wanted to take a look at what's happening behind the tub here. This is an exterior wall with the exact same insulation detail as we saw in the other part of the house, which is a 2x6 wall with fiberglass between the studs. and poly on the outside. And what we're seeing here in this particular stud is a great bit of darkening and little pathways. And we also see a bunch of the fiberglass has been kind of chewed up and turned into a different type of material. Well, that is classic mouse intrusion. So what we have here is mice have gotten into the wall. They have made pathways back and forth. You know that mice do not have any bladder control or fecal control, so they're peeing and the entire time. So this fiberglass has become their home and has been their home for 20 plus years. And as the house depressurizes because of the stack effect and has to repressurize, or there's wind blowing against the outside of the house, air comes through the exterior wall, through that fiberglass and into your house, which means that that air is bringing in mouse urine and mouse poop into your house. You're actually breathing that. And what we're going to do now is we're going to actually remove that poly, and we're going to take a look at what's really happening behind the plastic. So here we are in the bathroom, and I'm going to pull back the plastic to show what the mice have done to this. And one of the things we can see before we go in, even before we get there, is the insulation installation. How well the insulation is in the bay is not very good. So I'm just going to put my mask on because I don't want to breathe whatever's back there. Okay, just want to pull back and just take a look at, this is all mouse bedding. And you can see the pathways that the mouse have made. These teeny little holes are actually mouse holes. So as I pull it open, we should be able to find where the mouse were able to get to in the back here.
Okay, so let's leave this insulation.
And now I'm just going to put my mask back on and pull the insulation down. So what we're seeing here is mold on the exterior sheathing. This is CDX, also known as plywood, but it's completely wet, easily above 70% humidity, which is the humidity that wood starts rotting at. We see clearly mold here. And here, I don't know if you can see this, but all these little holes and all these pathways are the backside of the mouse house. And it's in not just this bay, but in the bay next to it and the one next to that. It's just worse here than in any of the other places. Okay, that's good. Cut that. This is an exterior wall outlet, and it has been air sealed in the past. Jim tried using these gaskets that you use in the supermarkets, or you can get at Home Depot, and these gaskets end up not being effective because the air just comes through the switch itself and through these small holes. So don't waste your money buying these switches, these switch and outlet gaskets. They just don't work. It's more peace of mind that doesn't work. So what Jim does when he insulates a gasket during insulation work is he actually opens up the entire outlet, pulls the switch or outlet out, and spot foams the knockouts. And then when he puts it back on, the cover back on, he uses a high performance caulk around the sheetrock to the box. And that gives you a relatively good seal on a retrofit. On new builds, we actually put the air barrier outside of the building so that this switch is always inside of the air barrier and you never have air leakage through them. Here we are. Jim's crew has removed the sheetrock, we're at the top plates of the first floor in the cape part of the house, which means that just above here is a roof line going up, and this space right above here is a knee wall. A knee wall is a space where the roof comes down and meets a wall. That space is often uninsulated, and what we have here is the band joist with fiberglass insulation. And installers almost always use fiberglass insulation here, but fiberglass insulation is not the material you want here, because fiberglass insulation, as my friend Jim always says, is like a filter at the end of a cigarette. It does hold warm air, but it does nothing for air sealing. So cold air and warm air can push through it, and I'm just going to pull this back. First of all, it's in two pieces. Should be in one piece if it's anything. And we see this has not been removed since 1989, and we have mold against the exterior sheathing, and the sheathing is wet. And this is not in the bathroom anymore. We're now in the living room. So there's no reason why that should be wet. But I'm seeing not just mold, but I'm also seeing actual water on the wall here. It's damp. So this is why we need to really be careful about air sealing. The reason we're getting moisture here is because of what's called vapor drive. In the winter, it's less moist outside and more moist in the house. The moisture moves through, trying to equalize the lower moisture content outside, and hits this band joist, which is colder than the dew point. At that point, it condenses against the wall. If it has a proper opportunity to evaporate and come back out of the wall in the summertime, when the vapor drive is from the outside to the inside, then you won't have a buildup of moisture like we do here. I'm actually feeling air coming through here, even though there's no big wind. So this is obviously a very leaky construction. So right above here, this wall, or this floor, is an unheated area outside of the house. So what Jim did when he was doing some work in here before is Jim actually insulated that cold space here in the ceiling of the living room. But this is not what we want to do with a knee wall space. There are two choices to insulating a knee wall space. One is the floor of the knee wall and the vertical of the knee wall, but it's not the right thing to do. We really want to bring that knee wall into the thermal envelope by insulating the roof rafters going down to this space here. So this is old building science idea that new building science has taught us is not a great way to insulate a knee wall space. So we're going to take another look at the vapor barrier here, not because we like poly as a vapor barrier, we don't, but because there's some other issues with it as a vapor barrier, not even thinking about what material it is. An interior vapor barrier, if you're going to use it to keep air infiltration out and control your vapor, needs to be contiguous. Contiguous means that it's sealed at all edges and it gaps. If we look over here, we can see that there's no tape connecting this piece of poly to the next piece. That means that air can actually move around that. It's not doing its job. At the top, where we get up to the band joist, there's no sealing to a contiguous air barrier going up and into the band joist. And here in the corner, they slit the air barrier, the moisture barrier, and didn't tape it. The issue with this type of not taping and holes and gaps is that here's a cut just in the wall. What we get is that we get what's known as the Venturi effect. We get an increase in the speed of the air that's going through, so it's actually transporting more moisture in one spot. This is not effective as an air barrier, not effective as a moisture barrier, and of course, as we said before, poly is a very bad idea because it has absolutely no ability to let any moisture through it at all, so it can trap moisture as well. About as bad as you can get with an installation for an air barrier, moisture barrier. What I want to show you in this shot is an effect called ghosting. If you look along the ceiling line here, what you're going to see is every 24 inches there's a dark spot on the ceiling. That dark spot is called ghosting. Ghosting shows us something called thermal bridging. The reason we get ghosting is because the ceiling joists cool down because the wood in the ceiling conducts heat better than the air spaces. So what we're getting there is at the ceiling joist that in the cold winter cools down below the dew point. Moisture in the air condenses against the ceiling at that point, just like water does on the outside of an iced tea in the summer. Dust in the air settles on that water, and as the water evaporates, it leaves the dust behind, which causes the ghosting. So ghosting is an indication of thermal bridging through the band joist, through the ceiling joist, and into the ceiling.